Welcome to Unit 1, Lesson 8, the nth term practice problems. Now, the nth term is also called explicit. So when we see that in the Delta Math and other textbooks, don't get confused. This text calls it the nth term. We call it, other places call it explicit. It's the same thing. Okay, first practice problem. They're telling you f of 0. So now we're starting at 0. We don't have f of 1. The first term we're starting with is called the 0th term. So this is a recursive sequence because we got the first term, we got the previous term, minus 5. So this is a recursive sequence. Explain why f of 1 is negative 20 minus 5. Because we started at f of 0 was 20, negative 20. So the first term has to be negative 20 minus 5. The first term. Since f of 0 was negative 20, the first term has to be the 0th term minus 5. Explain why f of 3 is negative 20 minus 5. Because we subtracted 5 3 times. The input is how many times you do the change. Complete the expression. F of 10 is minus 5 10 times. So 5 must be subtracted 10 times. Okay, now you see it starting again. We're starting at term 0. Not term 1, term 0. So watch. Term 0 gives us shorter definitions. Here we have our recursive definition. Now we want us to write an nth term or an explicit definition. So to write the explicit definition, f of n equals our first term, which happens to be term 0, minus 2 times n for any input. But n must be greater than or equal to 0. So in reality, explicit terms are shorter than recursive terms, and you can get to any term in a sequence. To get to the first term, you just put in 0 since they gave us term 0. If this was called term 1, that would get us to the first term. So the first term could be called the first term or term 0. Okay, now graphically, here's the difference. The recursive term, we have f of 1 at 3. So 1 is at 3. We're timesing by 2, which gets us to 6, which gets us to 12, which gets us to 24, which gets us to 48, which is just under 50. Okay, so now we see a curve. Find the first times of the sequence, first 5 terms. So 3, 6, 12, 24, 48. We graphed it. Is the sequence arithmetic? Is geometric because we're multiplying the same thing each time. And this is how we know. Now, see, because we started at 1, we started at 1. If this was called 0, our first dot would have been there. But because we started at term 1, our graph is shifted over to the right one. So be careful. This is the difference between starting at f of 0 and f of 1. It makes a difference on the graph. And also your next term must always be one more than where you start, what your first term is. So in the recursive, this is the first term. This is the next term. And the next term is always one more than the first term. Okay, so here is a graph of sequence M. Define M recursively using function notation. So recursively. All right, so 7. We started at 7. We went to 5. We go to 3. We go to 1. We go to negative 1. Okay, so this is f of 1. This is 1. How do I know it's 1? Because it's not on the it's not on the y-axis. So m of 1 equals 7. And then we're going down by 2. So m of any input n is the previous term minus 2, the change, for n greater than or equal to 2. Because this is 1, this has to be, the next term has to be 1 bigger. Now, let's write this explicitly. If I had to write this explicitly, I would say m of n is 7 minus 2 can't put in 0, n minus 1, but n must be greater than or equal to 1. One minus 1 is 0. 7 minus 2, no, 0. 2 times 0, that gets us to the first term. That gets us the first term. Okay, there we go. Okay, write the first 5 terms of each sequence. Determine whether each sequences are geometric. All right, so first term, the change. That's arithmetic. So 5 plus 3 makes 8, plus 3 makes 11, 14, 17. Okay, that was easy. Next one, starting at 1, we're multiplying by 3. That makes it geometric. So 1, 3, 9, 27, 81. Next one, we're starting at 3, times it by negative 1. There's no number after a negative sign. It means times by negative 1 plus 1. So this is neither. It would be neither if we were just multiplying by negative 1, but it's neither because we're multiplying by negative 1 and we're adding 1. So our first term is 3. Multiply 3 by negative 1. 3 times negative 1 is negative 3 plus 1 is negative 2. Negative 2 times negative 1 is positive 2 plus 1 is 3. And then negative 2 and 3. This oscillates back and forth. Doesn't grow, really. Okay. 5 is our first term. And then we plus n. So this is the step number. So this is neither, because we're not multiplying by the same number. We're multiplying by the step number. So for the first step is 5. For step 2, the first step is 5 plus 2, which makes 7. And then 7 plus step 3 makes 10. And then 10 plus step 4 makes 14. And then 14 plus step 5 makes 19. Okay? So the step number is the input. So step 1 was 5. Step 2 was 5 plus 2. Step 3 was step 2, the previous term, step 2 plus 3, and so on and so forth. Okay, here's a graph of a sequence. Is this sequence arithmetic or geometric? It's geometric. How do I know? It's a curved graph. And if I look at the output, 64, 16, 4, and 1 is divided by 4. List the first 5 terms of the sequence. 64, 16, 4, 1, 1/4. Write a recursive definition. We're starting at step 1. So what are we going to call this? I don't know. Pick any letter. J. J of 1 equals 64. J of any term is the previous term divided by 4 or times 1/4 for any n greater than or equal to 2. They should have asked us to write this explicitly. So if we had to write this explicitly, we could write, I'm just doing it. It doesn't ask us to do this. We could write J of n equals 64 times 1/4 to the n as long as n is greater than or equal to 1. We could put a 2 here, but then we had to put n minus 1 there. So whatever you like, however you like. If we started at term 1, our n had to be greater than 1. And we don't need to minus 1, but this is the way I wrote this one. So it's more about picking what is better for you to see. I personally like explicit terms without the n minus 1, but you had to decide what you like.